And I'm live. That is pretty cool. Today is 19th of November 2025, Wednesday, and with that, let's just begin. Go. And this Boot.Dev course on Go is actually pretty cool. Yeah, I mean, yeah, it is cool, comprehensive, and stuff like that. I guess after I'm done with this, the Go part in Boot.Dev, I would go through the whole back-end developer path course. That would be nice. That would be nice. Continue learning. I could continue from where I left off, or how do I see the whole thing? These are the courses, but there is a yeah. This is the page. Backend developer path. Python, Linux, Git. Git is amazing. Git is cool. And yeah, I guess I would go through the whole thing till here and learn how to find a job, programming job. That would be nice. And this has quite a lot of amazing things here. Docker, I don't know how to use Docker, so that would be a cool thing to learn. And yeah, that is what I would do. First, we will go through the Go course completely, and then wait, what? Reset course progress. Share to take it on again, I guess. First, personal project. What do we do in this? Build a personal project on your own completely from scratch, then submit to the community for feedback. Shit, that is like talking to real human beings. Start the course. Shit, okay, okay. This is nice. This is like actually pretty cool. Boot.Dev by Mr. Lane Wagner. And this is backend. So backend is cool. Then there are deep learning stuff. Learn, retrieval, argument, augmented detection. So, okay. And then learn HTTP protocol in Go. That would be nice. I think this is by Primogen. This course, yep, it is by him. So that is nice. And learn Git 2. This is also by Primogen. Kubernetes. I don't know anything about Kubernetes, so that would be cool. This is by Lane Wagner, and he has a child, and Don and Hunter Biden. Then learn CI/CD pipelines in GitHub. That would be nice. Learn cryptography in Go. That would also be nice. And learn data structures and algorithms in 2 in Python. And shit, the place where I left off, this when I was doing this for the first time, it was here. Here, yeah. Learn data structures and algorithms. Yes, I didn't want to do DSA. So yeah, that is cool. Yeah, shit. Build asteroids. How? What do we do at the end of this? What do we have at the end of this? Build asteroids, delta time, FPS. Shit, yes, we will go through the whole thing. That would be cool. Loop, game state, GUI. Sure, I don't remember doing any of this. So that would be nice. And back to learn Go. Yes. We were not at structs, we were at maps and slices. We did do slices. Slices, if you go back on this, and certainly not this. This is something more cooler can than Go. This is like, yeah, something tremendously more cooler than Go. Yes, slices and arrays. Slices are kind of references to in-memory arrays, and those arrays themselves could be on the heap or on the stack or wherever, depending on what the escape analyzer predicts. So yeah, that is what we learned about spices. Spices can change length and increase or decrease, go to the right, increase or decrease in size, and that is cool. That is cool. And they have the inbuilt feature or ability, you could say, by language, that if the underlying array to which a slice is pointing to, if that is too small in size, then the slice will automatically reallocate some new array with twice the required size and put all of that data from the previous array into the new array, and also append the new data which is supposed to be appended. So that is pretty cool. And the next thing is maps, and then we will get to pointers. That is cool. And then I guess instead of going from the start of the course, we will just take our own messy approach, learn memory management, and see this thing is cool, and this is by TJWs. Yeah, Tej. This is by Tej. He's cool. By Go, after Go, learn HTTP in Go. Wait, who is this by? This is by Lane Wagner, and why do we have this thing like twice? Learn HTTP servers. Wait, learn HTTP clients in Go, then HTTP servers in Go, and then learn HTTP protocol in Go. Okay, yes, they are different. Now on to maps. Let's map this out. Maps are similar to JavaScript objects. Makes sense. Python dictionaries and Ruby hashes. Don't know about Ruby. Maps are a data structure that provides key value mapping. Yes, yes. Zero. The zero value of a map is nil. Okay, nil is a value in this, and we can create a map by using a literal or by using make function. Okay, there are two ways to create a map in Go. One is by using a literal, or one is by using the make function. Using the make function, we do create a map, and then after creating the map, we provide some values. Or we can provide a map, or we can create a map like this. That is also nice by providing literal values in the map. This is map where the key is a string and the value is an integer. That is nice. The len function works on a map and it returns the number of key value pairs. That is nice, but how is this thing handling under the hood? We can speed up the contract. Nah, we aren't really doing the assignments. We will practice in the projects. That is the hope. And insert an element, just map key and key equals value something. And to get an element, map this key, give the value, and this is the element. That is also nice. And then delete is also nice, just like that. And check if a key exists. Check if a key exists. So this thing returns two things. And okay, that is also cool. If key is in M, okay, returns true, otherwise, and element as the value expected. If key is not there, then okay is false, and element is the zero value of the map's element type. Okay, that is also cool. Let's do some questions. Like, this is getting kind of boring. Just 2 minutes of this. And we could do code forces. Let's do code forces. There was this 95. That should be correct. Is that is correct? Code forces. There was a there was a question I did submit in Go, and mm, you have to close your eyes for this because white screen. Submission. This thing turned out to be wrong 3 times, and I think the code is correct, but the way that Go handles buffering when using print print statements, that is, yeah, we are messing up how Go handles printing to the screen. Here for taking in input we are using scanf, and for again taking in the input we are using scanf, and then for printing out we are using printf. But I think that is not the right way. Something is wrong. Something is not right. When we are running this code locally, this works as expected. But the whole logic of the code is correct. There is no problem with the logic. The only problem is with how we are printing, and that is what I think is the problem. Okay, let's get into how Go handles standard IO, right? Because I do understand standard IO, how it works in C++, and also in C, kind of same. If you know C++ standard IO, you know C standard IO. But I don't understand how it works in Go. So let's see standard IO, like standard IO buffers or something like that. Buff IO. Someone did suggest using buff IO. Um, yeah, shit. Someone did suggest using buff IO. Okay, let's write change the current code to use buffio instead of scanf and printf, and we'll see how it works. If it When should you consider using buffio? Shit. Golang buffio, a complete guide. Let's go through that. And okay, this is by Go, so this is better. Constraints. Okay, constraints. Max scanner token. Is there some data? Okay. Overview, package buff IO. Wait, this is a package and not a standard library thing. Not Rust, but Go. CDPF. And let me also change how assistant name works. Name with extension and okay. Shit. And the set, that is name, and here we'll make the same and import. Okay, it is something there. Okay, it wraps an IO reader and IO writer object, creating another object, reader and writer, that also implements the interface but buffering and some help for provides buffering and some help. .com/Golang. Let's literally read the source code of Go. I think we can do this. Source code and source buffio, but we want to see what FMT is doing when we call printf for scanf functions. Print, let's see, printf, and what do we have? Fprintf, nope. Sprintf, nope. Okay, so where is the normal printf? Do printf, nope. Printf, okay, printf is right here, and this calls fprintf. Printf takes string and then any number of arguments. Okay, and what does it do? It either returns a number and an error, and this printf calls fprintf, file printf to standard output format, and this format. Okay, format is a string. Format is a string, so pass out this string and all the arguments to fprintf, and here is the fprintf function. It takes writer, where we are going to write. It is standard output. We are going to write to standard output. What is the string that we are going to write? This thing, and the rest of the arguments. Then this thing creates a new printer. Okay, we have not used w yet. Okay, and then do print format a, print p dot do print format a. I think this function function is defined later in the code, so that is nice. And then we use the rw writer to write what buffer. Okay, so I guess this p has, yeah, this p is the return value of new printer function. Okay, and this new printer function returns some structure. That structure has this function and also a thing called buffer, and calling this do printer function on this p new printer structure, the buffer of this thing gets filled, and we are calling the w dot write, like write on os dot standard out dot write this buffer wherever this thing is, which is standard output, and take n and error and then free the thing, free this, which must be cleaning up the stuff. Yo, hello, at least learn my name now, lol. Shit, Archit Mishra, hello, how are you? Okay, that is nice, that is nice, I think. And okay, Archit Mishra, shit, I don't know if you are gone. I would like to show you my PPT for the assignment that I made. That is pretty cool, I think, the PPT that I made. Not this. Okay, shit. Formats according to format specifier. Yeah. Printf. And just wait a moment. Yep, I'm totally back. My bad. And yes, audio is visible, camera is also working, screen is also working. That is cool. Okay, shit, my bad. I had to go for a minute. I guess 2 minutes. Okay, and okay, let's simulate what the printf function does. Okay, yeah, let's simulate what the printf function does. New folder, simulation, and go init mod. Go mod init simulation. Okay, created and main.go. Okay, and here package main function. And what does this function do? Uh, we will have a string which we will print. So equals this should be printed, and yes, and we will have a printer equals empty dot. Okay, shit, what is this new printer function that they are calling? N is small. Okay, I guess this is their internal function which they are not shipping. Fmt dot, yeah, this is kind of, I guess, their internal function. They are not shipping this function outside. We can see new printer. Where is this defined? Shit, how do I see this? The whole thing here. Okay, it is not defined at all, it seems. No, right. This is nowhere. So yeah, let's just go to what the buff.io function is doing. Buff.io module does. Or let's see first how to use the buff.io module from this article. Introduction. Buff.io is a package in the standard library of Go that provides buffered I/O. It implements a buffered reader and writer that both implement the I/O reader and I/O writer interfaces. Okay, what is buffered I/O? Buffered I/O is a technique that allows a program to read and write data in chunks rather than one byte at a time. This is useful because it allows the program to read and write data more efficiently. It allows the program to read and write data more predictably. In Go, this is done by using the whole buff.io package. This package provides buffered readers and writers. How to use buff.io? The file we will be using in this guide is this empty file, creating a buffer reader. Okay, we have buff.io, OS, FMT, and formatter, and this OS. Okay, open the file. Okay, if there is no error, if there is some error, error is not equal to nil, then say this and return. Otherwise, differ. Yes, differ. If the file was opened, then we will defer the close function. And then reader buff.io new reader for this file. Okay, and create the reader. Print line reader. In the above code example, we are creating a buffered reader from a file. We are then printing the buffered reader to the console. This buffered reader is a pointer to a buffer.io struct, buffer.io reader struct, which we can see if you want to. Buff.io, buff.io go, yeah. and buffer reader struct. Okay, what is the reader pointer this function, whatever this read function is, it is taking pointer to this. Yes, reader struct. It has a buffer which is a byte, which is an array of bytes, and rd, which is io dot reader provided by the client. So the place from where we will be reading stuff, and r and w are both of type integer. Buff, read, and write positions shared, where the pointer, read, and write pointers are in the buffer. Error, last byte read by for unread byte, -1 means invalid. Size, last rune size, rune for unread, -1 means invalid. Okay, this is a buffer. This is a reader structure which has buffer, and I guess those are the two main things we have to take care of. Okay, that is cool. We have the buffer structure. Then reading, yes, read. There is a function for this thing in this called read. And there is a size function. Okay, these are declarations on this function. Reset, there is a reset function on this reader. That is nice. Peek is a function which is defined for this reader. Discard is a function which is defined for this. Read is a function which takes in a pointer to the reader, which we are calling b, and reads data into p. What is p? P into p. Okay, it returns the number of bytes read into p. The bytes are taken from at most one read on the underlying reader. Hence, n may be less, and this is cool. This is like genuinely cool. Lol. Yo, back again. Back into my old ways again. Shit. Okay. Lol. I remember what I said when you will start doing something actually the viewership won't be even half. Yes, PPT. When will you show? Okay, yeah, I was watching from 15 minutes back to see what I missed. Shit. Okay. PPT. Let me show you. I think I made it right. Google slide. Now this shit. White color. It's too difficult. Okay, this one. Icing model. Uh, this is too good. Uh, this is a PPT about how there is a D-Wave company called D-Wave, and they have a physical machine for doing quantum annealing, which is one type of quantum computing. And I had the assignment to explain what the model that they are using is called an Ising model created by a person named Ernest Ising, and yeah, how what the Ising model is, how it works, and how D-Wave is using that to solve problems, and what kind of problems they can solve. They can solve. They can solve graph coloring problems, and that is cool. And yeah, this like took quite a bit of time, and I guess I cannot give a overview over this. Yeah, this is kind of it. So what they do, okay, yes, I think I can give a overview. So what happens is there is a model called the Ising model, and this Ising model is defined is a quantum mechanical system, and in a system you there are a lot of configurations that the system can be in, and each of those configurations for a quantum mechanical system, there are a lot of configurations that this given system can be at, and each of those configurations have different energies associated with them, right? And there could be like a lot of configurations for a given system. If you have a system of, let's say, one particle, where you are only considering the particle's spin up or spin down, then in this case there are only two possible configurations for the system. One in which the particle has an up spin, and one in which the particle has down spin. Only two, and the energies for both of those systems would be same. In the same way, when you have a large number of particles and you are considering more than just their spin. So in an Ising model, the system is a bunch of particles and each of them have their independent spins. So yes, we have about n number of particles, and shit, this was about, so this stream was about to be Golang, so you picked it out yourself, or was it given not by university, for internship interview stuff? Yes, this was given to me. So yes, there can be n number of particles and each particle can have its own spin independently. That is two factors: n, the number of particles, and then the spin of each particle. Let's say qi is the spin of the ith particle, and now this system can have, since there are n number of particles and each particle can have up or down spin, there are in total 2 to the n possible states that this system can be, and each of those states have different energies, and there is a formula for calculating the energy of a given system if you know the spins of each particle, and that depends on what is the spin of neighboring particles. Like the spin of this particle interacts with the spin of the particle on its left and the particle on its right, and there is a certain coupling between all the adjacent particles, and there is a formula which is like I from I to n, I n minus 1, and there is a coupling which we denote by j, ij, I and I plus 1, coupling between I and I plus 1 particle, that is ith and the next particle, multiplied by qi, the spin of the ith particle, and qi plus 1, the spin of the I plus 1th particle. This is how we calculate the energy of a given system. But we can add like more detail to our system, and we can say for each individual particle, which can be electron or anything, we are going to have a magnetic field for each particle individually. And let's say the magnetic field for the ith particle is Bi, and that is also going to be added to our energy, and that is how we will calculate the energy of a given system for a given configuration. And what this company D-Wave does is it takes, and yes, now we can think of this as a algorithmic question. Yo, people are way too much interested in quantum mechanics, I guess. But isn't this based of QM model? Like, what does the Ising model does in this? Yes. Like, how does it leverage it? Can you tell some reference, like some blog post talking about this, or conference, or some research paper? There is a research paper which, yes, there is, not Feynman lectures. There was a research paper. I think maybe it was not this. No, no, not this one. I think yes, this one. This is cool. This is cool. I was not able to understand the whole mathematics that they were using in this. It is loading. Yeah. So this is the Ising model. Ising model says we have a lattice in some dimension. Maybe we might have a one-dimensional lattice, which is just a straight line, and at that straight line you will have n particles, and each particle will have up or down spin. So this is a one-dimensional Ising model. And given the formula for the energy of a given configuration, and a configuration in this thing is just defined by what are the spins of each particle. So what solving an Ising model means finding the configuration which will give the minimum energy for the system. And there could be two-dimensionalizing models like this, where at each lattice points we would have particles. And this is more complicated than this one because only adjacent particles were able to affect the energy, but here we have more freedom of dimension. So this thing interacts with the particle above it, to its left, right, and below. And that is the energy equation for this is more complicated than the one for one-dimensional Ising model. And so for one-dimensional Ising model, the original person who created the Ising model, Ernst Ising, he was able to solve the one-dimensional Ising model in 1924. But to solve a two-dimensional Ising model, it took us, I guess, 1944 or 1934, or maybe 44, I don't remember. Yeah, a guy solved two-dimensional Ising model in 1934 or some point, and not the full Ising model, because in two-dimensional, the one he solved didn't have any external magnetic field on each qubit. So yeah, because this is very difficult, and for any higher dimension Ising model, it is way too difficult, and these problems, the problem of finding the state with the minimum energy, is NP hard and NP complete. And what the D-Wave company is doing is, what is this? This is quantum computing. And what the D-Wave company is doing, since this is a NP hard problem, we can take any NP hard problem like the traveling salesman problem or graph coloring problem, and there is a mechanism through which we can translate these problems into an Ising model, right? We can translate these problems into an Ising model, and there is a whole process for translation, which is here, problem translation. And the one that I took, for example, was map coloring, and shit, there is a very good paper for that. This is a very good paper, I think. Yes, this is the one. This is the one. This is an amazing paper. Like literally, this is an amazing paper. And they also took the graph coloring problem or map coloring problem, and they explained how they can map any NP-hard problem onto an Ising model. So that is the one step, translating a problem, an NP-hard problem, onto an Ising model. And what their computer does is, since these are qubits, and they can be an up or down state at the same time, superposition. So we give this system a lot of energy called critical energy, and when the system has more energy than the critical energy, then this system can do a thing called phase transition, which is changing the configuration of the system. And yeah, changing the configuration of the system so that uh, its configuration would change, and hopefully it will go to a state which has lower energy, the lowest energy. So if here we are on the x-axis, if we are referring to different configurations and energy on this, then we give our system a lot of energy. And let's say we give our system a lot of energy, and the system is in a superposition of all of these states at the same time. And when slowly the energy goes away through radiation or something, then hopefully the system will land at the configuration which has the minimum energy. And then we will translate back that configuration which gives us the minimum energy back to the problem which we were trying to solve. And thus we will get the solution to that problem. No, no, I'm not building this in Go. My bad. Nope. Okay. This is the D-Wave paper. And this is cool. This D-Wave paper is quite cool. and the thing does not work. But this paper, this one here, this is quite a bit of mathematics. Math. Mhm. 1D and 2D as a model. Yeah, it does not. Oh, okay, so this is not the one. Yeah, this is the one, but it is just not working right now. But yeah, one of its uses is to solve some of NP problems, NP hard problems, and but there is also a lot of criticism for this. This method of using a quantum computer is called quantum annealing, and this okay. Let me also link the PPT. This method is called quantum annealing, and this is not very good because we cannot solve general problems with this method. We can only solve optimization problems with this method. And yeah, so people say that D-Wave is a scam and they are only solving problems which are just optimization problems. Yeah, so that is what people say about D-Wave. And yes, that is it. And back to Go. Let's go. To render from a buffer reader, you can use the buffer IO reader function. Buffer IO read function. Okay. Yeah. We get at this place reader, and this creates a new reader file. This gives us buffer IO reader. That is cool. And we did saw the structure of this thing. This is this. And I guess we just have to take care of these two entries. One is a array of bytes and the other is a literal reader, IO reader. And this is given by the client, the person who is calling this function. Okay, and to read from the buffer reader, you use the buffer IO reader read function. This function takes a byte slice as an argument. A byte slice as an argument. This byte slice is where the data will be read into. That makes sense. Okay. This is the place where the data will be read into. We create a reader for the file and we make byte slice data and we read into this thing. Okay, that is cool. And if we were able to read properly, then that is cool. And yeah, that is nice. That is nice. Okay, we are providing our own buffer and telling this buffer to read into our buffer. Okay, in the above example, we are creating a buffer reader from a file. We are then reading 100 bytes from the file into a byte slice, which we created here and then provided to the reader function. We are then converting the byte slice to a string and printing it to the console. The output of the program might seem like this. That is nice. Okay, let's read some files now. Let's read. Let's write a program that will read its source file and print it to the console. Yo. Import. Okay, shit, I messed up. Buffer and we need a reader. And we need to give in from where we are going to read. So how do we do that? Open file, os.open file. We take the file and we give that to the reader. Okay, and we can even go to the source code and see what this file thing actually is. Okay, in a minute. And file equals os dot open file main.go. Declared but not used error, is that the only error? Declared but not used. Wait, open. Okay, not open file, but just open. If f is not equal to nil, if there was some error, then we will say undefined must be open, makes sense, and return here defer file dot close, and yeah, then we will make our reader equals buffer dot new reader taken the file closed and not read. Now we will make our buffer where we are going to read the file. We will call it buffer, and that will be make. We are using make because we want to give it a size, and we want this to be a slice of bytes, byte, and the size should be, let's say, 100 might be too small, let's say 500. And yes, we need to call the reader function now. Reader dot read, and this taken the buffer, and what does it return? This thing returns a integer and an error. Integer indicating how much we have read, and error is if there is an error. So r dot u r equals this, and if err is not equal to nil, then print line err, and then we just return here and print line this buffer after converting the buffer into a string. Declared but not used. So main.go. Okay. Go run dot. Let's go. We got the source code, and this is 345 characters. So yeah, it is working. It is working. And let's see what this file is. And this is literally very cool. We can just go to the source code and see what these things are. We can see what a weak man is. Or this is in the OS thing. In OS we have test data signals exec. Nope. We need file related or open file.go. I think maybe file.go. Yeah, let's see. File.go. Import all of this. File. Link error. New file. Okay, they are taking pointer to a file type, but they have not defined the file type. They have a link error type. Yep, they have not defined the file type. They have said that There is a name function which returns f.name, but what is a file? IOFS. I think it is in the fs function. Fs module. Okay, fs is not here. Should have been here. IO. Okay, this is IO. Makes sense. Not in OS. IO. Here, IO module. In the IO module, there is the fs thing, and in that fs.go, let's see, package fs interface. Okay, there is some interface. Open. Yes, this returns a type of file. Okay, shit. This thing is returning a type of file, but we have not defined what file is. So file is defined in one of these packages or in another fs package. Format might be the thing. Okay, I'm just looking for the definition. There must also be like better ways for looking. Would I feel like you will read the whole source code like this? Shit. Yo, hello. Uh, many core production. Shit. Some TV people. And yes, I'm just looking for the definition for field. And this is cool. Okay, shit. We have some help here. We are using file here. And where is file? Definitions. File. Yes. Shit, that is cool. And this was inside object. Okay, I would not have predicted this, that this is an object file, object thing. Okay, we have a type structure OS. This points to os.file type and an array of a type called entries. And what is entries? Entries is this. Entries is a string and a raw file. What is a raw file? Okay, we don't know. It is raw, therefore it is classified. Okay, it is not classified. Raw file is an interface. So we have an interface. Shit, how do we have an interface as a value? That is messed up. Raw file. Okay, shade. This can have any structure which implements this interface. And the things are PCLN symbols, text. Text makes sense. Go arch. Let's go. Load address dwarf. Okay. And what is this? OS file. File pointer. Is this file? os.file. Os dot. So shit. This is something that should be in the OS module. Hopefully. Source code. OS. OS dot file. This is importing OS. OS dot file. Inside OS there is a thing called file. Inside OS there was a file called file. Yep, file.go. There we go. And file pointer os.file. Does OS have a variable called file? Well, it has quite a few things. Okay, it is implementing methods on the file data structure. Implementing methods on the file data structure. Okay. Okay. This is some detective work right here. Yo, you started a new series? Yes. Let's go. Last time you were doing DSA. Yep. You learning working of Go now? Yes. We just work Go. Clone it and we can navigate it using new go to definition. That will be easier. GHS shared. That makes sense. That makes sense, I guess. Also, C1. Okay, I don't understand this thing. C1. Okay, that makes sense. We can clone this and let's see how much time it takes. Golang Go master. Okay, shit. I do not want to copy paste the thing. Uh, I have other code bases also. I have the Linux code base, the whole thing, and this took a few hours to download. github.com/golang/go. This is a bit faster, and Linux code base is too big, also because of the Commits. Each commit, you are literally cloning the whole tree and creating new files. So that is very quite a lot of files. Shadow clone, you don't need full key shadow clone. Let's see. What does a wait, a shadow clone? I think I have heard about shadow clone. A shadow clone and Git refers to a shallow clone. This is a special type of repository clone that only downloads a specified number of recent commits rather than the entire commit history. Okay, so okay, we will get the current code base. That makes sense. That actually makes sense. If and whenever we are trying to go back in history, then we will download the new things whenever required. That makes sense, but let's get the whole thing. Here's what a shadow clone does. Okay, that makes sense. Okay, yes, that makes sense. Reduces download size and time because the way that GitHub works is like, let's say you have some file right now and you commit this whole thing. So not a file, you have a like whole tree, your directory has files, and directories have other directories which have directories and files. What happens is GitHub, Git, not GitHub, Git takes this whole thing and Git calls these files which have text in them, Git calls them blobs, and these directories which have files and directories within them, Git calls them trees. I think I'm right here. And yeah, there is a root tree also. And these blobs and trees are things. These are called objects combinedly. And your commits are also objects which have a certain data structure. They contain a commit simply has, and yes, all of these objects are defined by their SHA-256 hash. So yes, that is like a key value pair. The key is their SHA-256 and the value is the object itself. So a commit is simply the SHA for the root node, and that root node has the SHA for all the objects that it contains, and that is it. That is just the whole tree. And whenever we make a commit, Git goes through the root and sees, makes the SHA for all the files and compares them with the last commit and sees, is the SHA different? If the SHA is the same, then Git will not create any new objects. But if the SHA is different, then Git will create a new object, give it the SHA of the new file, and make the new root or whatever the thing is point to this new thing. And that makes sense. Good luck, yo. Dude, I gotta go. I am learning fast API right now. Let's go. Let's blazingly fast. Okay, and these things that we see, receiving objects, these are these objects, blobs and trees and stars, and we can even print these objects. If we go git no pager log graph, let's make a graph, and one liner, I think, and last two commits. Shit. We have to go inside. CD go. And now we do shit. Okay, it is one line, not one liner. We have these are the SHA of the last two commits, and I think we can even print them. There is a function in git not prune. Okay, log no git ls, I think. Git ls, yeah, git ls tree remote files. Git ls tree for we can use the, I think, the first six characters of this, or let's print the whole thing. So yeah, this commit has all of these files within them. The source file, the SHA for the source file is this, and the type of this thing is a tree because this is a directory, and this thing is a file, and the type of this thing is a blob. And yeah, similarly, then we can go and see to which things does this source thing points to, and we can see what happens there. Git ls, let's see the files within this source directory, source tree, and we don't have to write the whole SHA. We can, I think, use the last six digits. So that would be 7B815318B7. Shit, I think it does not have files. Tree does not have tree, not a valid object name. I guess let's use a few more digits from this. 5318B743. Invalid. Okay, I guess the first three things then. First six numbers. Git ls tree 5F6D627. Yes, that does work. And we have the whole tree. So that is good. And tree, what is files? It says empty and remote. I don't know what remote does. Fatal. This does not appear to be a remote. Git remote thing. Okay, that is nice. Let's clone it. Shell. You don't need the full history. Yes, makes sense. Git is also a cool command. Git ftx. What is git ftx? Git ftx. Uh, uh, no manual entry for git ftx. Git clean ftx. Okay, it is a an argument to the clean command. This is a powerful git command used to remove untracked files. Okay. Uh, Shit, this is similar to Go's garbage collector, untracked files. Files which do not have any trees pointing to them. That is cool. And directories from your working directory. This commit is often used to ensure a clean working tree, especially. Yeah. F means force. D means this option tells to remove untracked directories also, which means trees. And then X, git clean to remove all untracked files, including those ignored by git ignore. Files normally clean would not. clean the files which are by git ignore. So that is nice. That is nice. And going back to this here, let's go to source code and not go io io.go reader interface. Yep. What were we even looking at? We were in file. We wanted to see what file is. Okay, okay. That is cool. That is cool. We have seen that file is pointed to a file. And yes, yes. Shit, the stream was going to end, I guess. Yeah, cool, cool. Okay, okay. We are not dead. Okay. So there is this thing where file is defined. Oh shit. fs fs.go okay, file shit. Go to definition is not working here. Go to definition is literally not working here. Yes, it is not working. Yeah, when go to definition is not working here. I guess we will have to use GitHub GH, even though it is not very good. I have to use my mouse. But this thing is cool. I get all the symbols here. Okay. Yes, file, and file is defined in there was file definition of a file is in this thing object file.go, and my thing is that this is kind of inheritance. My understanding is my noob understanding after looking at the source code for a minute, for some time. This file object file.go defines a generic definition for a thing called file. This has a generic definition for this data structure of a file, and then other modules like the fs file system module or the os module, they are all importing this. They all import the definition of the basic file structure from this, and then in our program in our program, and yes, what do they do with this basic definition of a file? They add their own methods. So fs adds its own method and os adds its own method, and I think I have evidence of this belief. Source, if you go to say os and file.go, let's go to file.go, and this thing, yes, right here, this thing is adding a method called name to the file type, and this is also adding other methods, link error, this, okay, these are not for file. Yeah, this is adding read at method, read method. So these are adding their own methods to the basic file type, and in a program, if we import file, the file structure from the OS module, then we get some methods which were added to the file by the OS. And when we import fs file from fs, we get some other methods. And so that is kind of like inheritance. Yes, back to GitHub. My bad. Let's use grep or fuzzy find and all. Shit, I have not used fuzzy find. I do have this. Okay, let's see. Um, telescope. Where is telescope? Telescope right there. Okay. Leader ff for find in files. Description find files. Okay. Live grep. We can use live grep for by using fg and leader for help. So where do we have to be? File grep. Okay, now we are in file grep. If I write file grep. Okay, file live grep. This is live grep. We are not seeing. Where are we seeing things from? Are these inside the file? Okay, yes, these things are from inside the file. That is nice. File reader. These are all the things which have the file reader thing. Shared, yes. In this file, on this line, at this character, we have the file reader thing. Okay, this not there. Okay, things which are calling the file reader. Uh, new file function, places where the new file function is being called or maybe defined. os.new file, os.new file, new file, new file. Yeah, that is cool. That's cool. What does the other one do? Find file. Okay, this is just for looking files. That's cool. io.go, there is just one file or multiple files. And this is also considering the fact that we maybe messed up and we are not typing the right thing correctly. That is cool. And this is going through the whole code base. So that is cool. And shared. This file, source internal object file, macho.go, hasn't been updated till 2013. Maybe we can make a PR onto this thing. rn to get the line number, relative line number. Shit, where I think this interface is working. Cool. Telescope. This is by Teach DeVries. Okay, yeah. I don't know why the thing does not work, but this interface is like better without the go to definition feature. I don't know why go to definition is not working. Why would it not work? Okay, we did see what file does, and cool, and we even have a theory about what is happening with the file structure. There's a basic file structure which is being um, imported by the modules, and they are adding their own methods, right? Reading from a buffer. We know how to read from a buffer. CD simulation. Yeah, we know how to read from a buffer. So that is cool. Let's see now. Yeah, we read 100 lines and do this, creating a uh, buffered writer. Yes, that is what we need for our main code forces thing that we began this whole shebang with. Why do you use NeoVim more than the terminal? Like, yeah, NeoVim is good, but you over reliance is not. No, NeoVim is good. NeoVim is good. NeoVim is good. I even share. I don't use CD and all that. I just go there, uh, go to this netrw, netrw when I want to go somewhere in the file system. This is cool. This is cool. And creating a buffered interface writer. To create a buffered writer, you can use the buffer IO new writer function, and we will go through why we were seeing error by when we were using a scanner, and hopefully using a buffered writer works for however the code forces online judge expects us to answer, or yeah, to put stuff in the buffer. To create a buffered writer, you can use the buffer IO new writer function. This writer takes an IO writer as an argument. This means you can pass in any type implementation with IO interface, any type that implements IO interface. This includes OS file, string buffer, and not or and bytes dot buffer. OS, okay. We have created a file. Share, that is what they meant by os.file. You can create a file, add stuff to the file, defer file.close, writer, new writer, get a writer, print line. We are printing the writer. In the above example, we created a buffered writer from a file. We are then printing the buffered writer to the console. The buffered writer is a pointer to a buffer buff.io dot writer struct. Back to the source code. Okay, buff.io. This is in buff.io. Yes, we'll use GitHub for navigation purposes. Buff.io and scanner, new writer size, new writer takes in a buffer IO. Okay, and new writer size is this thing. Okay, what we were looking for, what is buff.io dot writer data structure. So writer, return a reference to a writer. So writer is error buffer IO writer. Okay, bytes and a writer, IO dot writer. And when we print this, I guess we will get the bytes writing to a buffer. Create a file, get the buffer, error, write. This is string, convert this is string into a byte array and write that to the writer. This will create a file called file.txt and write hello world to the file. Yep, this function will not write the data to the file until we call buffer IO writer dot flush. Function is called. Okay, we will flush the thing afterwards. Terminal, most of my commands that I say is for terminal unless specified otherwise. Shit. Okay, I will remember that. But yeah, grep is for terminal, but we get live grep in NeoVim using telescope. That looks cool. Change the buffer size. Okay, let's write something to the buffer. We need not go. Okay, we will read stuff that we are reading. We will copy that to a write buffer, and yeah, we will copy all of that to the write buffer and write it to another file called main2.go. Okay, at this point we have the data. We do have the data, and new writer. Yes, and file equals with.create main 2 dot this. It returns two values. Okay, my bad. And if error is not equal to nil, there has been some error, and we will say print an error and return. Otherwise, here defer new file dot close, and we have our writer which will take in the new file declared and not used. That is the error. Okay, we have our writer. Now we will write stuff to this writer. N comma error, and this equals writer dot write, and this will take in a byte string, which we can just say buffer. Okay, either we can just pass in the buffer, which should have worked, but it does not work. Okay, why is n an error? Declared and not used, and that's fine. Writer dot write defined has no method write, but does have a method write. Okay, it does not have a method write, but it does have a method called write. Okay, capital. Okay, yes, here we can either pass this buffer that we are passing, or can we not pass the buffer which the write reader has? I think not, because this might error. So first we have to make sure that we have the buffer completely and then pass on the buffer. Okay. Okay, at this point we must have written the file, and now hopefully we have written the file. Println m and fmd dot println this comma file written successfully. Go run part 500 file written successfully. That is crazy. We have written the whole thing. That is messed up. We do have a file main2.go which is empty because we didn't call the flush. Makes sense. We have to call the flush function flush after writing if error is not equal to nil. There was some error fmd dot println. Otherwise here flush. Okay. Yeah, this does work. And okay, file is too small. Too small. Okay. The buffer size is too small. Let's increase the buffer size by 500. Now it is 1000. Go run current thing. 1000 things written. And let's also stop. We might see error. Yes, we do see error because now we have two functions. Go run dot. Okay. 6100 characters were read and we wrote 1000 of them. Into.go, and yeah, we messed up in this part. Let's pass in not the whole buffer but a part of the buffer. Main.go. Here, we are passing the whole buffer. We do not need to pass the whole buffer. Right buffer? No. From the start till R. That should work. Main2 dot go, and then yes, we are only writing as much as we read. So that is cool. That does work. Okay, let's remove all of this. And we will use the same buffer IO syntax and code forces. Buffer IO imported but not used. That is fine. Like totally. Reader and writer. But shit, okay. We can say that we are going to read from a standard input or output. Yes. Here. And this might be dumb, this might not be the go way to do things, but okay. We need a reader, new reader. This will take in os dot standard in. Reader is this. Don't use this. Okay, we have the reader, and we will also check for error. Does not give any error. That is nice. We have the reader. Okay, we do have the reader. Now we need to read into T, but we can only read into bytes. Okay, shit, no. There must be some other way to do this instead of. We also need a formatter to read in the correct way. Yeah, how to using the, yeah, what is like the way? Input reading read right from file in Go. No, FMT scan. Okay, we can use the FMT functions. It seems in order to follow this post, we will need to have Golang and Python. Okay, on a recent reading input from a standard in Go and in any other language is not a tricky thing to do. Actually, it is quite easy in Go. You could achieve this simply by using one of these. These functions are the standard for reading and from the standard in, but for large inputs, they don't perform too good. Let's see why and what could we use instead. On a recent post, who's this person? We'll shit. He's a newbie? Shit, he's writing posts. That is cool. 42 problems. That is the answer of the whole universe. 42. Shit, bro's actually good, I guess. This was back in 2021. Shit, and he was writing articles. That is cool. Blog post. The program on a recent post, I wrote about the issue that I was having related to time limit exceeded error TLE on my submissions, writing in submissions written in Go, even in a ridiculous way. Given that an implementation of the same algorithm in Python were acceptable, while my Go implementation were not. Almost all of my submissions written in Go faced TLE, so I decided to dig a little further on the issue. Okay, after profiling a program that receive an input in this way, like this, where the first number is the number of test cases, the second number is the number of elements of an array, and the next numbers are those elements. So number of test cases 1, 4 elements, and these are the 4 elements. I wouldn't do anything fancy with this input. I'll just read them and see how fast Go can do this using FMT scans functions. This is the code I am using. Let's see it in the main package. Okay. Parse for the help. Flag.string. They have a thing called flag.string. Convert this thing into a string of some sort. Then parse flag. If CPU profile is not equal to empty, then os.create CPU profile and defer this. Okay, start time for the CPU and end time for the CPU. That is cool. Go, we can do this. Okay. Start CPU profile and stop CPU profile if pointer to CPU profile is not null. Like if this is running locally, I guess. Write CPU to the file. Okay. Flag dot parse. Not equal to null. Okay. And then okay, here we go. TC is a integer and scan into TC. Then I smaller than TC. Go for each test cases. Use scan and use print ln for printing. We are using scanf first of all, and second for printing we have printf. I guess scanf and printf are not the way to go. Maybe. How are they using printf? For scan they are just using and this thing scan into this whatever the type of this variable is, I guess, and then println they are, yeah, it has formatting of its own. Okay, let's use these functions. Shit. Was that the whole thing? Shit. If this was the error, that these two things had no space in between. If this was the error, then that was very stupid. Let's see. This was the genuine error. Shit. There was no space between two different characters. Yeah, I guess I can move on to projects. I also want to go through this thing. I'm gonna code, go, and the problem is be set of strangers. Let's go. Yeah, let's go. Shit, this might. Okay, this is running. That is good. If we get correct answer on test case 1, which I think we are not going to get. Yeah, wrong answer because we printed the wrong thing. Yeah, we did print the wrong thing somehow. Let's not use this. Okay, somehow we are not getting any errors. Scan percent and here also. Let's use this and yeah, printf. I think we can use the genuine printf function or shit println the response. And here instead of scan. And if we were to do go run go build output out the set.go dot flash out, run this and copy this whole thing, paste. Yes, we do get the right answer 0 to 110, which is the correct answer 0 to 110, but it just doesn't work here somehow. And yes, about projects, I want to go through this whole Boot.Dev course from start to end. This seems too fun. This has Kubernetes and Docker and projects also. And this is cool. Okay, running on test case one, hopefully. Okay, shit. Okay, okay, shit. Okay, now this will work. That was the problem. So using printf and scanf was giving us error, but using print and TLE. Okay, so this is slow. I think we should listen to bro. The first part of this program is just runtime p profile program profile to make the profiling of the program. Now you run this program with a small input. You won't have any issues related to performance. The problem starts when we try this program with an input with large amount of elements in the array. Let's write a simple script in Python to generate an input file. Okay, how are they? To generate an input file, open this thing in write mode as f. And while this is open, f dot write one with a new line and then write this number 22 million and one in range, write 1. That is the size of the array. Okay, we are just writing 1 1 1 1 1 in the whole thing. And now profiling. Now go build main python app.py, create the output file. Profiling, take the profiling, share out.prof. They are doing something. This thing creates the profiling, which is in.large. This file is called in.large, but there you are, they are calling it input and out.prof. Run main, give this argument, CPU profile is out.prof, and we are giving this thing input large as an input. This is for inputting to this thing as the standard input. CPU file, CPU profile, which we are passing in here. Okay, whatever their means is. And they see some bad things, I guess. Oops, that is a lot of syscalls. All of these syscall. 46% syscalls. All these syscalls are due to repetitive call to print to fmt scan to read the elements of the array. So what could we do to avoid all this? Let's make the same thing different using buff.io package. We could read these elements. The code would look like this. Read int and read line numbers, read array int, and they have functions for all of these things. And buff.io is faster than the basic fmt input. We create a new reader, and that is the only reader we will use throughout. Okay, and tc read int for all the test cases, read in and read array in. What is in is using this buffer, using this input buffer, read from this read integer, read int and read array, but read array is going to return an array. We are not reading the array, it seems. Okay, test case done. We are not storing the array. Read line numbers. How are they reading the input? Read a string from this input buffer, read a string till we encounter a new line. Okay, till we encounter a new line, or maybe a space would also be there. And then replace all return carriage with empty and new lines with empty, new string, and then string convert this to this. Read int. I guess this should be replaced with space or a new line character, anything, because the next thing could be a space or a new line character. Okay, this is they will only use this for the places where there is only one integer on a line. And then read number lines and return a string line. Read a string, read the whole thing, replace all new line, return carriage and new line with this, and split this and return. This will be returned as in string. Okay, strings dot split. Okay. Read array, read line numbers, read array integer as an integer. Read line numbers. Okay, this thing now nums is a string, is a array of strings. And then we create an array of integers. We are going through everything individually, and we are putting the value here in the array, and then we are returning the array. Okay, let's use this format. Let's use this format. Okay. Starting from the line 69. Yeah. Func read int doesn't take, this does take in reader, buff IO reader. Yes, this takes in a reader, and let's call it R, and the type of this thing is buff IO dot reader. That is the type, and this thing will return an integer. Okay. Okay, and line equals R dot read till. How do we say read till? Read a string till we see a new line. Okay. Read string until the first occurrence of the delimiter, which is a string. Okay. If air is not equals nil, if we were not able to read, then we will say empty dot, or we just empty dot, or we don't, let's print. Shit, my camera is now working. Okay, okay, it was out of commission. Hello, how is everything? How is it going on? I cannot read, and here we will return the and I wanted to exit, but let's panic. Func check, this takes in e error and doesn't do anything if e is not equal to nil. If there is some error, then panic with the error. And check error. Cool, cool. We have the line now. Split equals strings dot substitute replace in this line every occurrence of a new line with empty undefined strings. Okay, not enough arguments in a call. Want an integer. It wants an integer. Why would it want an integer? Replace all. Replace all. Okay, how many? You want to replace all of the things. Not replace all occurrence in line whenever we see a return carriage with empty and return not a toi who has the ATI function. Stir convert has the ATI function. ATI line. Okay, we have a read integer function read line as a string r buff.io dot reader, and this will return a split. No, not a split. What do you call it? A slice of strings. Okay, line dot error, keep reading, read string till we see a new line, and check error. Okay, now we do have the line. We will split the line on spaces, and also let's replace line equals strings dot replace all in lines, replace all the occurrences of a new line with empty things, and with a return carriage. I'm good. Let's go. Let's good. Okay, let's go. I read it as a D. Okay, and now, yeah, now we can just return by splitting this thing. Dot split at the occurrence of a space. That is nice. Read line nums buff.io dot reader. It takes in a buff.io dot reader and it returns a slice of integers. Read string whenever we see a new line till we see a new line, and then check for error, and yeah. No, we don't need it. We don't really need this. Yeah, it's stir array, read line string from R, and yes, we have this. Now we need to convert everything in this thing into a integer, right? Response will be make an array of integers where the size would be the size of the array, and then for index comma n range stir array, stir array, we'll say res I will be equal to stir convert dot atoi, which thing n. Atoi n is a string return value too. This thing gives us two return values. Okay. Return res. Okay, we have the functions which we will be using. Okay, let's also move all of this logic into the main function. Let's create a reader equals from where. This will come from IO buff IO dot new reader, and new reader from IO dot stand. Should this IO dot standard input, IO dot standard input, that is a place, that is OS. Shit, yes, OS. It should come from OS. The reader OS dot standard input. OS is not defined. Let's define OS and create T. Read int from cannot use in variable of this as of reader in argument. Compiler cannot use in variable of type buffereader pointer as buffereader. Okay, so this is a pointer to a buffereader. Let's say we want a pointer. That works. That does work. We have T. T is T. Yep. Instead of scan, we will not use scan. We need N and M. Numbers equals read line nums, and N equals nms dot 0 and M equals nms dot 1. Right. And then we create our grid and we put stuff onto our grid, which we don't actually have to do. We can just say grid I equals read line nums from input. We have the whole data, and that works. That does work. That does work. Now we want to print this integer. Yes, now we want to print this integer. I guess we can convert this into a, we need a writer for that. Writer equals buff.io dot new writer. I guess we can keep the same writer. Yeah, print. Yeah, we can keep the same writer. Writer is fine. Go build slash out, run the whole thing, and copy this. Yo, what are you doing? I'm trying to work out Go. here we are getting time limit exceeded error when we are using scanf. So we are reading this article, and this person also faced the same issue. He said he was facing a bottleneck, a TLE error, and we are seeing how he was using buff.io for solving his problem. We are getting the right answer, so the logic is correct, hopefully. Let's submit and hope this works. 96 lines of code is too much. If this works on test one, then it, I guess probably, okay, it did work on test one, so that is nice. 6, 7, okay, we are moving ahead, running on test 12. I guess we are cool here by using buff.io. So I guess Go is not very cool for competitive programming because we had to write our own functions for reading and writing. That is not bad, but this thing, the thing that I don't like is, I guess we can define our custom functions to fix this part. Here we had like 4 things in the input, and yeah, that is because of the fact we only have this function which reads numbers like this. Yeah, which reads numbers uh, per line basis. That is not very good. Okay, so we did do competitive programming, that is working. So how about writing a C binding for taking inputs in Go for absolutely no reason, of course, but just for learning and see how easy is it to do C file input in Go. Okay, I'm getting scared. How do we do this then? And yes, I guess we have gone completely away from what we were doing. Okay, how to use C in Go. Import C, literally we can import C. Okay. Import C, fmt, and C dot my function. We can call the C function here. Back and Go. Uh, C dot. Okay, now the camera is going to die. Phone, yes. I bet. Ah, shit. Let me put my phone on charge. Cool. Okay, we can import C, the C standard library. And then we can call the functions and get the return values. And what about the compile time? What do we do at compile time? Go build, go install. Nah, bruh. Okay, shit, capital C. Okay, it was capital C. It is working. Let's remove this whole thing. And num equals C dot. That is how it was. Yeah, C dot square root. So we call it square root function. And C dot double to get a double. C dot undefined C dot double. So square root is defined, I guess. Then fmt dot println num. Go list fail. I guess we have to add C to the dependency and slash golang slash go do we have in the source file something called C? We do not have here. Should have been here. C. If we did have that as a thing. Cgo. We have Cgo. Import C hash include. And okay, we and flags include C with this. References and shit. I just don't want to read through this thing. Just it. And this is development side go. Yeah. Don't want to read through that just yet right now. Duh. Of course, it was never primarily made for it. It was made mainly for servers and such, and for very fast compilation. Of course, yes. I meant I didn't. I mean, it doesn't take minutes for just a simple hello world, like some language like Rust, I guess. Yeah, and this one of the weird quirks of it, which I feel weird about. Okay, you need to write the C code in comments. It is not like even write C code. Search for CFFI. Okay, and go. Then you will get something accurate. Look for a directory called FFI or CGO. It might be named something like that in the source code, I think. Okay, CFFI Golang FFI FFI. I feel like I've heard FFI. Foreign function interface. Share like this. And where do we call this? We call this here go per string. Convert is go string to C string. C string name, and then we can call the function. That is nice. Import unsafe. Can we just run this thing as it is? We do see errors. Dot go. Let's see. Source and go per or wait FFI or CGO. Foreign function interface. Let's see CGO. CGO is not here. Nope. And FFI. F no, FFI is also not here. And this thing is also giving us error undefined go string. Could not determine what c.free refers to. And everything else was okay, I guess. Let's not free. Google unsafe imported and not used. It was supposed to be an unsafe. Okay, no errors. Literally no errors. That is good. And now can we do um on c dot it's okay, not use this. Okay, okay. Dot slash b set. Yo, that does work. That does work. That is cool, but we didn't free our string, and I guess this might have been on the heap, so we had to free this. C dot free C name and import re or something was the name. Import unsafe. Unsafe imported but not used. Undefined this, undefined C string. Now everything is undefined somehow. Go build output out B set dot go. We don't know what that free thing refers to. That is good. It does work. Printf. Okay, we can just write a single function which does everything in C that we want it to do. Let's say this thing doesn't even take this argument. Yes, and here we have some C code and we will say char pointer name equals hello there I am Mr. Robot, and then print if just the string with a new line and pass in the name fit semicolon also has to be there. Hello there, I'm Mr. Robot. Yes, that does work. So that is cool. Okay, what is in the lib folder? We will see. Search for how to compile C Go programs. I think you need to clarify what C compile, which C compiler to use and such. Shit. Now it is working. We can just put everything we want from C in Go and basically write our whole thing in Go. But we also need the side effects, the return values, and give input to Go. Hydration. Shit. And okay, yes, I will have to end the stream. I have my interview on at 2 o'clock. Shit, yes. Today's stream will be short. It is short, just 2 hours. Now I will have to end the stream. I have my literally my interview at 2 o'clock. Yes, and the slides that I showed at the start. The best by far. Yeah, you need to think for the best. C for an interface was in D shared. Yo, thank you. And let's go. Let's go. Let's see what happens. And that would be the end of today's stream. And thank you for being here. Bye.